54. It says, for a fundraiser, the theater club is making 400 cookies. They want to make twice as many chocolate chip as peanut butter cookies and 3 times as many peanut butter as oatmeal raisin cookies. Determine how many of each type of cookie the theater club will make. Show your work. I know what they should make is they should make 400 chocolate chip cookies because they're just, let's face it, chocolate chip are that's the king of cookies. Okay? In fact, oatmeal raisin cookies annoy me a little bit. Why? Because you see the raisins and you think they're chocolate chips, and then you bite in and it's a stupid raisin instead of a chocolate chip. They trick you into eating something good for you, and I don't like that. I want my chocolate chips. But anyway, notice how peanut butter is compared to oatmeal raisin. Chocolate chip is compared to peanut butter. So oatmeal raisin is where I need to start. Chocolate chip compared to peanut butter compared to oatmeal raisin. Oatmeal raisin is where I start. So I let X equal the number of, and if you don't have this, you need to write this down, of oatmeal raisin. And then they say that there are 3 times as many peanut butter as oatmeal raisin. So what's 3 times X? 3X. So 3X is the number of peanut butter cookies. Now, I still need to represent the number of chocolate chip cookies. So it says they want to make twice as many chocolate chip as peanut butter. Not twice as many as X, twice as many as 3X. What is twice 3X? 6X. Twice 3X means 2 times 3X, 6X. That's the number of chocolate chip. Now, since they're going to make 400 cookies, if you're in my house, you better make 500 if you're going to take 400 somewhere. Anyway, if they're going to make 400 cookies, doesn't that mean if we add the number of oatmeal raisin plus the number of peanut butter plus the number of chocolate chip, that equals 400? Does that seem reasonable? All right, it's easy from here. Because X plus 3X is 4X, plus 6X is 10X. What's 400 divided by 10? Yeah, it's 40. So, if X is the number of oatmeal raisin, and X equals 40, that means we have 40 oatmeal raisin cookies. 3X is the number of peanut butter. Now that we know X is 40, what's 3 times 40? What's 3 times 4? 12. So what's 3 times 40? 120. Peanut butter. All right, there's 6X chocolate chip. 6 times 40? 240. Chocolate chip. So once you get this one set up, it's not very difficult. It was just confusing to set it up. Any questions on 54? All right. From the ones you did last night, what else would you like for me to work with you? Okay. Let's take a look at these. Because you guys know how to answer these, I think you just didn't understand what they were asking. When it says name the congruent sides and angles in a figure. Let's do 64 first. I'll do 64 and 65. Looking at 64, it says name the congruent sides. All right, well look, see how that side or that segment's marked congruent to that segment? Those segments are sides of the triangle. So segment AB is congruent to segment AC. And we have named the congruent sides. Well, then look how angle B is marked as congruent to angle C. Those are 2 of the angles of the triangle. Angle B is congruent to angle C, and we've named all the congruent angles in the figure. So when we get to 65, which is a little more involved, let's look. See how we have 1, 2, 3, 4 different segments with one hash mark through them? That means those 4 segments are congruent to each other. And all 4 of those segments are sides of that figure, aren't they? So if I write GF, segment GF is congruent to segment LF, is congruent to segment HJ, is congruent to segment KJ, I've named 4 congruent sides. Now, GH is also then congruent to LK, isn't it? They're not congruent to the other 4, but they're just congruent to each other. So I'm also going to say that segment GH is congruent to segment LK. And I've named all the congruent sides. Now I'm going to name all the congruent angles. Help me out here. What angles congruent to angle G? Angle L. What else? Angle H. What else? Angle K. So those 4 angles are congruent to each other. What's congruent to angle F? And we've named all of the congruent sides and all of the congruent angles, haven't we? So you see how to do 66 and 67 now, don't you? Okay? Any others we need to go over? Turn to page 51. We're going to do 22, 23, 24. Then we'll do a few others. 51. Page 51. All right, number 22. You were taught in Algebra 1 how to solve a system of 2 equations with 2 variables. But I don't want to do that if I don't have to. I would much prefer to have an equation, to have one equation with 1 variable. So when I look at 22, notice that this angle, the one that's labeled 8y minus 101, and this angle, the one labeled 2y plus 7, are a pair of vertical angles. Remember, vertical angles, when you have 2 intersecting lines, the non-adjacent angles are the vertical angles. Angle 1 and angle 2 are vertical angles. Angle 3 and angle 4 are vertical angles. Then we had the theorem that says vertical angles are congruent. So, back to 22. Since those 2 angles that I marked in red are vertical angles, they're congruent to each other. And congruent angles have equal measures. So that means that the measure of one of them, 8y minus 101, 101, must equal the measure of the other one, 2y plus 7. I'll pause here while you write that down. In the book, it says 102, so change your 101 to 102, and it also says 6 instead of 7, doesn't it? I'm glad you caught that, or we would have gotten the wrong answer. All right, let's subtract 2y from both sides. What's 8y minus 2y? 6y minus 102 equals 6. Now let's add 102 to both sides. That gives us 108 on the right. And what is 108 divided by 6? I got 1 vote for 18. Any other votes? 18 it is. All right. Now we've got y. We need x. Okay. Maybe the vertical angles thing will work again. That angle and that angle are vertical angles. That means they're congruent. That means their measures are equal. Oh, see where this kind of falls apart? I can call that one 3x if I want to, but that doesn't help me solve for x, does it? So I'm going to have to try a different pair. So we learned about vertical angles in this section. We've also learned about linear pair. So look here. If I look at that line, and look, I'm going to ignore all the rest of the figure. Okay, pretend it's not there. Look at the red line and the red ray. Aren't those two angles right there? Don't they form a linear pair? Because remember what a linear pair is? Adjacent angles that form a line. That's not the definition, but that's my paraphrase. Adjacent angles that form a line. Well, those two angles are adjacent angles, and they form a line. So they are a linear pair. We have a theorem that says the angles in a linear pair are supplementary. The definition of supplementary, or at least my paraphrase of the definition of supplementary, says if two angles are supplementary, add their measures together and it equals 180. So I should be able to add 3x plus 2y plus 7 and make it equal 180. Now, I kind of broke my rule about not having two different variables in one equation. Or did I? What can I replace that y with? 18. Now that I know that y equals 18, replace the y. Oh, I did 7 again, and it's really 6, isn't it? Replace the y with 18. I can solve this. So I get 3x. What's 2 times 18? Plus 36 plus 6 equals 180. What's 36 plus 6? 3x plus 42 equals 180. Now I need to subtract 42 from both sides. Now be careful, when you're subtracting from 180 or you're subtracting from 90, it's easy to be 10 off. So what's 180 minus 42? 138. And now I need to divide 138 by 3. 46. Any questions on 22? Yeah. There's one on your quiz that you'll take Tuesday where you have to find two variables for one problem. So you'll need to list them both. So that's a good idea. Circle them both. All right, we're good with 22? Let's take a look at 23. So, again, I would much prefer to have one equation with one variable. So find all the equations that have an x in them. Those two, right? So I need to try to make an equation with those. Or at least not without one of the y's in there. As far as well, they're not vertical angles. So as far as I know, they're not equal to each other. That's a line. So they're not a pair of vertical angles. They are what kind of a pair? Linear pair. So I need to set this equation up like I did the last one. Since those two angles form a linear pair, then they are supplementary, which means when you add their measures, it equals 180. So 7x minus 248 plus x plus 44 equals 180. Solve that for x and see what you get. What does x equal? Anybody got it? Close. No. 48. All right, let's take a look at it. Now that I unfreeze that. Simplify before you solve. 7x plus x is 8x. And here's where you might have some trouble. It's negative 248 plus 44. When the signs are different, you actually subtract absolute values. So I get 204. But since the negative number had the bigger absolute value, it's a negative 204. Now, I need to add 204 to both sides. So 180 plus 204 is 384. And then I need to divide by 8. And if you want to use a calculator as you're doing this, that's fine. That's no problem at all. So we got x now. All right. I'm going to give you a hint, and then I'm going to make you find y by yourself. Here's your hint. Write down the equation you think you should use to find y. Is that the equation you wrote? Now, you could have written the 5y minus 17 first, but those two angles that have the y's in them that I've outlined in yellow form a linear pair. If two angles form a linear pair, they are supplementary. If two angles are supplementary, then when you add their measures, it equals 180. So that's the equation you need. Now solve it and see if you can get y. I know some of you got y equals 21. Questions? All right. Now, I thought 22 was fairly difficult. I thought 23 was fairly difficult. I think 24 is just flat out difficult. All right? Didn't say impossible. And I also didn't say that I didn't expect you to be able to work a problem like this. Because I do. I do expect you to be able to work a problem like this. All right. The trouble we have is that they tell us more than we need at any one time. Okay? They do this quite a bit. And we have to decide what's useful and what's not. And what's useful to find x may not be the same thing as what's useful to find y. So first I'm going to try to find x. And look at what I'm outlining in red here. And ignore the one I didn't outline. Ignore that blue line. And just look at the red ones. This angle and this angle are vertical angles, aren't they? And vertical angles are congruent. And congruent angles have equal measures. So 5x plus 4 has to equal 114. That's a simpler equation than we've been having. So let's solve that. Let's subtract 4 from both sides. So 5x equals 110. What's 110 divided by 5? 22. Very good. Now we've got to find y. So finding x was a little bit easier than I thought it might be. Now we've got to find y. Now when I look at y, I've only got the one expression that has a y in it, that one right there. So that's got to be in my equation some way, right? Now, this angle that's labeled 2y and this one over here that's not labeled, they are vertical angles. But since I don't know the measure of either of them, you know, I mean, I don't even know, I don't have anything over here. I can call it 2y, but setting 2y equal to 2y doesn't allow me to solve for y, so I don't think I can do the vertical angles trick again. It's not trick, the vertical angles technique again. So, once again, I'm going to choose which part of the figure I'm going to use. I'm going to use this line, and I'm going to ignore everything else over there. And now look what you've got. You've got 1, 2, 3 angles. If I add the measures of those 3 angles together, considering that together they give me a line, if I add those three measures together, what should I get? 180. Okay? So I'm going to add 114 plus 2y plus 3x minus 24. Because when I add those three measures together, it gives me a line. It gives me a straight angle. It gives me 180. And then I'm faced with the same dilemma we had a couple problems ago. I've got an x and a y. But look, I can fix that, can't I? So let's fix that. So that's 114 plus 2y plus 3 times 22 minus 24 equals 180. All right, I think I'm going to get my calculator out now. So let's add together all the numbers on the left side of this equation. Let's simplify the constants. So I've got 3 times 22, that's a 66. I wish that would stop doing that. So that's a 66. So that 66, I need to subtract 24, and I need to add 114, don't I? Oh, and how did I get two numbers? So I went 66, subtract 24, add 114. Nope. All right, is that right? Hit enter, just hit it once, just once. All right, 156. So I've got 2y plus 156 equals 180. What do I do next? Yeah, so 180 minus 156, what am I going to get? 24. And so y equals 12. Can I have a woohoo? All right. Questions? All right, flip over to page 52 and draw this figure. We're going to do 29 through 32. And we're going to use that one figure for every one of those. So it doesn't have to be a great drawing. I don't care if you freehand it or use a straight edge. I don't care. But draw that figure because we're going to write all over it. Number 29. Let's label. If the measure of angle KNL equals 6x minus 4. So find angle KNL on your figure and label that 6x minus 4. And the measure of angle LNM equals 4x plus 24. So LNM is that adjacent angle right below it, 4x plus 24. Find the value of x so that angle KNM is a right angle. That's really important, isn't it? Angle KNM is a right angle. Label that as a right angle. Now, I'm not labeling those two angles congruent. Those aren't little arcs. That's the perpendicular box, the right angle box, the 90-degree box. Okay? Oh, the 90-degree symbol. So if I add those two measures together, what should I get? 90. 6x minus 4 plus 4x plus 24 equals 90. Solve that for x and see what you get. What does x equal? It does. Add 6x plus 4x to get 10x. Negative 4 plus 24 is 20. subtract 20, divide by 10. All right. We okay with 29? If you need this, write it down because I'm getting ready to erase it so I can do the next problem. Okay. What you need to do is erase the measures you just put in on your drawing. Erase those measures because number 30 has different measures. Now, I'm going to erase the work I did just because I need the room. Don't erase your work. Number 30. If the measure of angle JNP equals 3x minus 15, so I'm going to label angle JNP 3x minus 15. And the measure of angle JNL equals 5x plus 59. Now look which one is angle JNL. It's this one. So its measure, you got to make the arc go from one side of angle JNL to the other side of angle JNL, is 5x plus 59. Find the value of x. Now, they give us more of a hint here than they need to. I already know the equation I need to use. But they make it even more obvious. So that angle JNP and angle JNL are supplements. If they're supplements, that's another way of saying that they are a pair of supplementary angles. And when you add together the measures of supplementary angles, what do you get? 180. So the equation we need is 3x minus 15 plus 5x plus 59 equals 180. Does that equation make sense to you? All right, solve that. What's x equal? It does equal 17. 3x plus 5x equals 8x. Negative 15 plus 59 is 44. Subtract 44 from both sides. 180 minus 44 is 136. Divide both sides by 8, and x equals 17. Okay. Any questions on 30? We've got 2 to go. So are there any questions on this one? No. All right. Once again, erase the measures you have on your drawing because we're going to put new ones on there. Number 31. If the measure of angle LNM is 8x plus 12, so label that on your figure, and the measure of angle JNL, all right, JNL, we just worked with that one, so it's this one. Angle JNL has a measure of 12x minus 32. Now they finally, instead of just saying find x, they say find the measure of an angle. But we got to get x first. What's our equation going to look like? That is exactly right. Because those two angles form a linear pair. This is the line they form, isn't it? Since those two angles are a linear pair, we have a theorem that says linear pairs are supplementary. We know that supplementary means when you add your measures together, you get 180. So solve that for x for me. You able to get x equals 10? All right, we simplify first. 8x plus 12x is 20x. 12 and a negative 32 are a negative 20. Add 20, then divide by 20. Now, we got to do a little thinking here. Help me think this through. They ask us for the measure of angle JNP, which is this one over here. They don't give us an expression for that one. What expression can I use for the measure of angle JNP? Which one? 8x plus 12. Here's why. These are a pair of vertical angles. Vertical angles are congruent. So if the measure of one of them is 8x plus 12, then the measure of the other one is 8x plus 12. So that's 8 times 10 plus 12. What's 80 plus 12? 92. Make sense? Okay. Erase the figures, or erase the measures you had on your figure, because we've got one more problem to work using this figure. Number 32. All right. If the measure of angle JNP equals 2x, y'all do it. Label it. Label your figure. And then check to see if you labeled it the same way I did. Okay, now, write your equation. Yep. Is that your equation? Now, let me clarify something. They're not a linear pair because there's three of them. However, those three angles do have to have a sum, or those measures have to have a sum of 180, because together they form a line. So we don't call them a linear pair, but they end up working the same way. All right, solve that for x and see what you get. X equals 20? Are we finished? No, we're not. Find the measure of each angle. Now that we know x equals 20, we can do that. So the measure of angle JNP is 2x plus 3. That becomes 2 times 20 plus 3. What's 2 times 20? 40. And what's 40 plus 3? 43. Now, the measure of angle KNL is 3x minus 17. What's 3 times 20? And 60 minus 17? Also 43. Yeah, so those two are congruent. And then the measure of angle KNJ was 3x plus 34. What's that end up equaling? Questions?